Hi everyone, this is Boutong Huang from Alibaba. So in this demo, I'm going to present Grosbeak. It is a data warehouse with resource-aware incremental computing. And this is a joint work between Alibaba Group and UC Irvine. So resource skewness is a big problem in a lot of enterprise data warehouses. And we see the same problem in Alibaba as well. So what happens is our business data continuously come in during the day. However, since the analytical queries typically want to analyze a full day worth of data, they cannot start at all until end of the day when their inputs are fully ready. As a result, this makes our cluster extremely busy during the night, and a lot of free cycles during the day are wasted. So we built Grosbeak. Following the idea of an early bird, we incrementally execute the queries during the day as data are coming in, so that we can schedule these small batch jobs utilizing the free resources in the cluster. And dependent queries can be executed together like this. So in this demo, we selected a simple two-query workflow where the first query simply joins a fact table of logs with a dimension table of users and calculate a click data for users. And the second query simply aggregate this table and produce a click rate result. Okay, let's start the demo. So the window in the top shows the cluster frontend, and the lower left window shows the outline of the demo. So we feed in this simulated cluster load into the scheduler. And let's say early in the morning, the cluster load starts in medium state. And then in the terminal, I'm gonna submit those queries, sending their outputs to the background. And at this point, the input table for both queries are empty. And now we see both queries started running. And then for each query, we allow users to specify a cluster load threshold so that the query can only run incremental jobs when the cluster load is below that value. So here, we configure Q1 to only run in medium or low state, and Q2 to only run in low state. And then next, let's say by 10 a.m., Q1 has accumulated enough input data beyond some threshold. I'm gonna simulate this by inserting some data into Q1's input table. And now Q1 will say, I have enough data, I'm ready for an incremental run. And then since the cluster is in medium state, the scheduler will go ahead, call Q1's optimizer, generate the incremental plan, and submit it into the cluster. If we open Q1's front-end page, we can see more details about query 1. So here, the blue box is Q1's long-running control logic, and the first yellow box, job 101, is the first incremental batch job, and the dot 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 to the right means that we're still in progress and waiting for more future data. And if we scroll down, we can see more details about this job 101, where there's 4 stages and a bunch of parallel instances per stage. And if you want to see the job structure, and then we can double click this job 101. So here, the 4 green boxes are the stages, and the gray boxes are the input and output tables. And if we double click this third stage, we can see the detailed physical plan within the stage, where we read in both tables, do a simple join on the left, and outputs this view result. Note that this table will be part of Q1's final output table. And also, this table will be immediately available to use by Q2's incremental run down the stream. And besides that, this plan also saves another table, which is an intermediate state, which will be used by Q1's later incremental runs. And okay, and let's come back. Note that in general, to trigger an incremental run, the query need to accumulate enough input data, and also the cluster load need to be low enough. And both threshold value are configured by the user. So now let's say the cluster becomes busy and a bunch of data arrived for Q1 as well. And Q1 will still say, I'm ready to run. But since the cluster load is in high state, the scheduler will simply ignore it for now. So if we refresh the front end, there should not be any change to Q1. And next, let's say by 1 p.m., the cluster becomes less busy and drops to medium state. And now Q1 is eligible for its second run. So the scheduler will call re-optimize into Q1's optimizer. And the optimizer will make some adjustments and issue the plan for 1 p.m. and submit it into the cluster. So if I refresh the front end, we will be able to see the second yellow box, which is the job 201 here. And if we further zoom in, you can see that this is basically an incremental join between new tuples coming from the logs with the other table, dimension table of users. This is actually the state we saved earlier at 10 a.m. and produce this delta result, which will be part of Q1's final output. And also this will be available to be consumed by Q2's incremental run. And next, let's say by 3 p.m., the cluster further dropped to low state for the first time. And note that since the two runs of Q1 earlier has both produced some outputs for Q2 to consume, Q2 has been ready to run for a while. And now this is the first time where the scheduler will call Q2's optimizer and generate a plan for 3 p.m. and run it. And if we open Q2's front-end page, we actually will be able to see both Q1 and Q2 here, simply because Q1 is Q2's dependencies. And we see that this first red box job 101, and if we zoom in, we see that it actually consumes both tables produced by the two yellow boxes of Q1 earlier and do some calculation and produce its own state for the first time. And in general, when the pipelines are deep, a cluster load job can potentially trigger a cascading runs of downstream queries, one after another. So next, let's say at 6 p.m., Q1 has accumulated enough data again. Since the cluster is in low state, this will trigger the third run for Q1. And if I refresh again, so we will see the third yellow box here. And the data it writes will immediately trigger the second incremental run for Q2, which shows up at the second red box here. And then finally, let's say we arrived at the end of the day when the cluster becomes extremely busy. And we let Q1 know that all its inputs are now ready. And then for the final runs, the scheduler will always ignore the cluster state, simply because the final runs always produce the final result. So this last job of Q1 will prepare the final output for Q1 and then exit. And then the data it writes will trigger the last run for Q2 as well. If I refresh again, we see the third job of Q2 actually already finished running because there's no more ... to the right. And the job status becomes success and the terminal thread also exited. So this concludes the demo. To sum up, Grosbeak is a data warehouse that can optimize resource usage with incremental computing. It can handle arbitrary query pipelines thanks to its cost-based incremental query optimizer. And with the ability to adaptively replan, the execution becomes very flexible. And we believe that this is a very interesting direction for both research community and the industry. Thank you.